So, hello everybody, my name is Sitnik. Today I would like to talk about exceptional exceptions, but before I do so, I introduce myself. So, at Everyday I work at Powell. We create software for energy producers and distributors. So, in general, it's the kind of software where exceptions are not welcomed. And in my free time, I contribute to open source, all of the things related to performance in .NET. So I'm one of the core contributors to benchmark.net. I also did some optimization in Core CLR and Core FX Lab. So instead of agenda, I would like to give you a few questions, and I would like to answer them today. So have you ever wondered if finally blocks are guaranteed to be executed? So when you are typing finally, do you think that it's going to be always executed? Have you ever encountered an exception that omitted your catch blocks and anyway killed your entire process? Very good. Have you ever encountered a silent error? So something was definitely going wrong, but there was no exception. Great. Have you ever failed to find this answer for exceptional behavior? So instead of doing any more debugging, you just said okay, I just rewrite that and do this in other way. No? I'm the only crazy guy here, okay. So, and maybe you have measured performance, so how much does it cost to throw the exception and catch it versus returning a simple false? Okay, so this is the kind of thing I would like to talk about today, and let's start with a simple example. So time ago, I had received a bug report, and the logs contained a single exception. And this exception was saying something about that the channel was in the wrong state. But the call stack was starting at dispose. And I was like, okay, so only releasing the resources didn't work out. But the support said that nothing has worked out. We did nothing. But I decided something is missing, and I decided to analyze the code. So what we were doing is that we were creating an instance of a WCF client, opening the connection, calling a save method, and then in the finally, we were disposing the connection. And I was like, how is it possible that save didn't work out, but the dispose has thrown the exception, and I got no other data? So after some brainstorming, I decided to ask myself the following question. What happens if a finally block fails with an exception? So we got a throw which fails, and a finally which also fails. And what are we going to catch? How do you think? Is it going to be the first or the last exception? Yeah. Yes. Most of you were correct. The last exception, here the second. So, why is that? This is how C# is implemented. But the problem with this behavior is that we miss the real information about the real problem. In my example, I was getting an exception when I was opening the connection. So the real error was saying, I cannot connect to remote machine, but I was disposing and getting the exception overwritten. So what can we do about that? We just need to keep our finally blocks extremely simple. No chance for throwing the exceptions. And if you ever encounter this situation, single exception, something starts in a finally, then you can be sure that most probably something has happened before, and you are missing part of it. So, speaking of finally, is it guaranteed to be always executed? No? Otherwise, I'll probably not ask this question. So, on Stack Overflow, I found two answers, but with some books, I got a few others. First of all, .NET is managed word. If somebody is bypassing the managed way and calling the native APIs, then the CLR is not aware of that, and the finally blocks are not going to be executed. And this is a case today, because thread abort was not ported to .NET Core, so people do native calls. And the behavior is going to be different. Second option, environment fail fast. So when we decide to fail fast, none of the finally blocks are being executed. But the good thing is that objects that derive from critical finalizer object, their finalizers are going to be executed. The next thing, corrupted state exception. I will talk more about that soon. And the last thing, the obvious one, somebody pulls off the plug. So of course, impossible to execute. And what can we do about that? Some people say that there are two things that you can be sure of, taxes and death. And I would say that third one is software failure. And you just need to prepare for failure. You cannot avoid failure. One day it will catch you. And it might be a problem for you or not. For example, today I'm developing a system that when we sell some energy, we need to update the production plan. And if we don't do that, we have a problem. But here we got Rabbit, here we got Oracle, here we got Microsoft SQL, no way to do distributed transaction. So what I recommend you is to prepare a recovery plan, if it's needed. So what happens to the resources when the process is killed? The good thing is that they are being released by the operating system. So when you cannot edit a file and you kill a process, you can edit it. So what you should avoid is to rely on some custom behavior, like sending a goodbye message to some queue, for example. Because operating system is not going to do that. It has simply rented you the resources, and when it's killing your application, it's simply releasing the resources, but doing nothing else. So this is why people implement stuff like Heartbeat. And first exceptional exceptions that I would like to introduce is thread aborted exception. This exception is being used to signalize that thread was aborted. We can catch it, but even if we leave the cache empty, .NET will rethrow this exception, because this is its internal signal. But very interesting behavior of thread aborted exception. Can it interrupt the finally block? No, it cannot. So we could actually create following code. We got two things that we want to execute together, no matter if thread is aborted or not. We can create an empty try and put the code into finally. So the thread abort cannot happen inside the finally. But first of all, I didn't make this on my own, and I verified it works. The knowledge comes from a great book called CLR via C#. But anyway, if you would like to use this in your code, please leave a comment, because otherwise one of your colleagues that is using ReSharper will simply press Alt-Enter, and your trick will be gone. So, how to minimize the chance for failure in the finally block? First of all, we need to be very simple, just releasing the resources, nothing else. Second of all, we need to be defensive. So before we free the handle, we check if it was allocated first. And with latest C#6, the code gets even simpler. Of course, if you are using the using keyword, you got this out of the box. But the last thing that you can do is that you can also use constrained execution regions. And what is that? So how to use it? Before entering the try block, you add single instruction. But how does it work? So before entering the try block, the CLR is going to do following things for when, catch, and finally blocks. It's going to load all of the assemblies used in these blocks, compile them, and run static constructors for types used within these blocks. But these things apply only to non-virtual methods which have the reliability contract attribute applied to them. It will also check if 48 kilobytes of space is available on the stack. 48 is because this is the size of average method from some .NET statistics. So, by using this constrained execution regions, we can eliminate this long list of exceptions. But the thing is that we are not going to eliminate them, but provoke them at different time. So if we have a following example, where we have a finally block that has a static constructor that fails, and we have a constraint execution region before, then the try will never be executed, and the method will throw on the upper level, and anyway, we need to catch this exception and handle it. And you might think, why would anybody use that? So this feature is, for example, used in databases like SQL Server. So if you cannot deallocate a resource, don't even try to allocate one. So the usage is quite limited, but very powerful. But let's talk about exceptional exceptions now. So which exception is the first that comes to your mind when I say exceptional exceptions? Okay. Okay, I've got more of them. First chance exception. It's not an exception, it's an event. And this event is being raised by CLR when exception occurs, but before it decides to search for the catch blocks. So, recently we had a following problem. Our application was working perfectly fine for some time, and at some day it stopped working. And we didn't want to introduce WinDebug because a junior developer was responsible for that. And I told him, please sign up for the first chance exception and see if nobody is swallowing the exception. And the result was that some part of the code, a third-party library, was swallowing the exception. And with first chance exception, we know that exception occurred. And in my opinion, in a well-written application, if everything is working correctly, you can have this turned on, and no exception will be flowing anyway. The next exceptional exception. We got common language specification that says, any language that wants to be compatible needs to give us a way to catch and throw exceptions that derive from system exception. But we got managed C++, which is supposed to be compatible with C++. And in C++, you can throw anything, integer, datetime, string. And in .NET, we can do this as well. But the good thing is that if somebody decides to throw anything, .NET is going to wrap it out of the box for us in runtime wrap exception. So if you have a catch block that catches any kind of exception, whatever it was will be caught. And if you would like to do that in C#, we can create a dynamic method, load the argument on the stack, and simply throw. But please remember that this is an anti-pattern. Please don't do this at the production, only for demo purpose. So when we are invoking such a piece of code, then the message of the exception will be following. An object that does not derive from system exception has been wrapped. So anything can be thrown, not only exceptions. Okay, now reflection. Sometimes we need to invoke a method with the reflection. But the problem is that reflection wraps any exception. It wraps them in target invocation exception. So if you have some GitHub code and you would like to use some internal method and this method throws some exceptions, then you don't prepare for that, but only for the target invocation exception, and then you need to unwrap it first before you can handle it. So how do you think? Does the dynamic wraps the exceptions as well? If reflection does, should dynamic do? No, it doesn't. So we get the original exception when using dynamic, which is very good. The other wrapping takes place in exceptions that are being thrown in static constructors. So where a static constructor fails with an exception, it's being wrapped into type initialization exception. Another surprise for us. But the most important thing happens when we invoke native code from the managed code. And as you know, native code can fail with an exception as well. So there is a translation. If there is one-to-one, we got the exact same time. Otherwise, it's structure exception handling exception. But the most important thing is that CLR supports us type and memory safety. So when it sees that we went to native code, got access violation exception, then it decides, look, no more memory safety. I'm shutting down. So you can actually catch these exceptions, except Stack Overflow, if you add these two attributes to your method. So at my first job, we had a WinForms desktop application, and it was being killed few times in a year without any reason, even if we had the catch in the main method at the bottom. So the answer was that it was a native exception. We didn't have this attribute, and it was killing our application without any notice. And this was changed in .NET Core. And just a little reminder, .NET Core is not a replacement for .NET. So a breaking change in .NET Core, it means that it's different than the original classic desktop.NET. So if there is something good like performance improvement, you will get it in classic .NET Desktop. But if there is a breaking change, you won't get it. So in .NET Core, they decided to not allow this attribute to be used anymore. So we cannot use the native exceptions. We cannot catch them. And I believe this is good in terms of security and safety, because somebody thrown the exception for a reason. And before I speak about next exception, I would like to show you a demo. So time ago, when I was a junior developer, I got a bug report. Our application is not resizing. I was like, it's resizing to me. Could you be more specific? Okay, it's not resizing on Windows 2008 when there is a lot of nested controls. So for this particular example, it was resizing. But if I add few extra layers and just change the color for the purpose of the presentation, the behavior is different. No resizing. And even no repainting, which you will see just in a second. So, at this point of time, I knew that no exception is being thrown and no exception is being logged anywhere. And I was like, okay, what's going on? I verified all of our code and I was sure that we are okay. But it was a very good practice for doing Google search. What do I need to put in the Google to get the result? So the answer was that Windows was preventing from Stack Overflow exception. At some point of dev, it decided to not give the event to the rest because it could cause Stack Overflow exception. And Stack Overflow exception, you cannot catch it, and it will immediately shut down the process by calling the environment too fast. So, how can we avoid that? We can use tail recursion, and if you are an F# developer, and the return from your method is the last thing in your recursive method, then the F# compiler will do this for you. If you are a C# developer, then you have to implement tail recursion on your own. You could also redesign your code to use iterative approach. The thing is that it's not always easy, and even sometimes it's impossible. You could also set a limit, but if you ever do so, please log warning somewhere so anybody else will know that something bad have happened and the application is not working for a reason. What you could actually do is also to ensure the sufficient execution stack, which throws an exception when there is not enough of space. Not enough is, once again, 38 kilobytes. And in .NET Core 1.1, which was released 2 months ago, you can call a method that simply returns Boolean. But in general, recursion is not bad. And Stack Overflow is not very common for recursion. So you need to know your domain and your code. If you are sure that you know your input, and you just verify that it works for the possible input, you don't need to worry about Stack Overflow exception. This is not the way to go. Recursion is a very good thing. And my next question to you is, can out of memory be caught? Yes. Who thinks yes? Who thinks no? Okay. Because it depends. It depends on who tried to allocate the memory. If we developers tried to create new object, array, or did boxing, we can catch it because it was our fault. But if CLR try to load the assemblies, JIT the code, or do any other internal allocation and failed, then we cannot catch the out-of-memory exception. And there is a long list of reasons why we run out of memory. First, most common is, of course, memory leaks. So this is obvious for us. The other one, the heap got fragmented. Large object heap is being maintained by free-list algorithm, so you might actually have in total the needed space, but not a single element that would fit your need. But in .NET 4.5.1, a new setting was introduced. You can compact this heap on demand. But what I would advise in terms of performance, don't try to handle this exception, prevent it. So you can actually use some pools like RI pool from system buffers package, and then you won't have any problem with heap fragmentation in the large object heap. The other reason might be that you just hit the 32 address space limit, which is 2 gigabytes. And remember, in Visual Studio, by default, you have enabled a checkbox in the properties of your CS Pro, which tells prefer 32 bits. You need to check this off. You could also try to allocate a very large object, which is not possible by default. You need an extra setting to do that. What else? What was really crazy to me, it happens to me at least once. Our application was working perfectly fine on some remote machine. We didn't touch it for 2 months. And the support called us, look, the client says it stopped working. A lot of out-of-memory exceptions. Have you touched anything? And I'm the guy that does the optimization, so everybody was looking at me if I broke up something. So I said, no, didn't touch for 2 months. And I asked them, any Windows updates? No. Any other updates? No. The reason was that some other very memory-hungry process used all of the possible memory at the server, and we were trying to get only this little to work in normal way, and we were failing. So if you are sharing the computer with some other bad process, you might get problems with memory as well. And of course, operating system tries to prevent that, but it's not always perfect. And what else might happen is that somebody might have set a limit for the maximum available memory for your process. So this is also a possible option. Next very exceptional exception, execution engine exception. So have you ever seen that? No? So it's being thrown by CLR when it detects a bug in itself. And it happened to me when I thought that I'm good at IL, and I did some testing, and I, of course, broke things up, and the CLR was just shutting down. So no catch, no finite blocks will be executed after that. And now we enter the world of asynchronous programming. As you know, in .NET 4, we got tasks which represent an asynchronous job. And most of the people chain tasks one by one after one. But what most people don't know is that you can chain them in parent-child hierarchy by using attached to parent property. So we can actually have a single parent with multiple childs. And this is why the property error of task returns aggregated exception, multiple exceptions. But okay, let's say that I have this method that throws with 2 exceptions, and I'm awaiting it. So which exception is going to be caught? Aggregated exception with all of them, aggregated with one of them, first, last, random. Yeah, we would like to get all of them, but what we get is aggregated exception with the first exception inside. This is the limitation of the asynchronous state machine implementation for today. And if we want to handle these exceptions, we need to make one step back. But it's very important because it was a silent error because we just lost the information about exceptions. So how can we do that? First of all, we got the task, and then we create an error handler for that. We use the continue with. Does anybody remember this method? Yeah, async await everywhere. So we say unfolded, do that. If okay, do that. And then we await any of them. But what's important is that the aggregated exception might contain other aggregated exceptions, because multiple childs might have multiple childs. So we need to flatten them first before we handle that. And how to deny child task attaching. An extra option to start new, which is the default for task run, which is just an alias to that method. And this is very important for the library authors, because your responsibility ends where you have returned your task. You don't want other people to attach some child for that. But what about fire and forget? So we got a method that fails, and we start task for it, but we never save the reference, we never await it, we never check the result, we just forget about it. So the tasks have finalizers. And as you know, in .NET, we got single finalizer thread. So if there is a deadlock inside finalizer thread, no any other finalizers are going to be executed as long as this process is alive. This is why finalizers are eventually executed. So when it's eventually executed, task checks. Have I been ended up with an exception? Okay. Have anybody seen it? No? Okay, then there we have an unobserved task exception. And there is a separate event for that, which we can sign up to. But the most important thing is that we need to mark it as observed. If we don't call this single line of code, this exception remains unobserved. And what happens with unobserved exceptions? What you would like to get? Death of the process or silent error? Death. The old .NET chose death. But remember how finalization works. Finalizers are executed after GC is collecting memory, and GC is non-deterministic. So you might get into a situation when a user of your application is using it, this exception occurs, but no finalizer is yet, then the user goes for a coffee break, comes back, starts using your application, allocates memory, GC starts working, finalizers are being executed, and you got an exception, which just killed the process. And the user calls you and says, look, I went for the coffee, came back, and it stopped working. And then you do the same, and it still works for you. And you just mark it as unable to reproduce. But it's not the option here. So in .NET 4.5, this is a silent error. But if you would like to enforce immediate death, then you need to apply this single line of code in your app.config file, which I really recommend you to do. The last exceptional exceptions are the unhandled exceptions. So in the modern .NET, it's immediate death of the application. But there are few events that we can sign up to and still handle the exception. But I don't recommend you doing this, because at this point of time, you have no idea about the context. You just have the information about the exception, and you don't really know if it was serious or not, because, yeah, a null reference in some points might be serious, in some not. So I would rather not try to handle this exception here, maybe just log it and fail fast. But the problem is that we have the event for unhandled exceptions for app domains, which were not ported to .NET Core, and for other .NET frameworks or technologies, we got different handlers, different for WPF, WPF, WinForms, WebForms, ASP.NET. So it's really hard to handle it correctly. And now, the most interesting part, performance, of course. So, how much does it cost to have just an extra finally block? No exception is being thrown. So let's measure that. We got an empty method that cannot be inlined, and a benchmark that calls this method. So this is cost of just invoking a method. And another benchmark which has an empty try and a finally. So the difference is 2.5 nanoseconds. So this is an extra cost of having the finally, without any exceptions being thrown. And just a reminder, you need 1 billion of nanoseconds to get a nanosecond. So it's not a lot. It's not a huge overhead. This is why we should not give up on finally so easy. The next situation is following. We have only throw statement in our code. We are not throwing anything. Does it cost anything? Let's have the benchmark. In the middle, the code that you have just seen. On the right, a simple property that just returns the value. And on the left, a code with a trick that I'm going to show you. But do you know why the difference is so huge? Also, so the code on the left also contains if statement. The reason is that, yes, stack call, because stack call is needed when method is not inlined. So if you have any exception handling blocks inside your code, it's not inlined. And it's a problem for the small methods. And if you take a look to core CLR, to arrays where they are supposed to have very fast indexers, then they have a single class called throwHelper, and every single class that throws an exception in core CLR calls this class to throw the exception. Because if we do following trick, like moving the throw to other method, then the if is going to be inlined. So our bad scenario is not going to be inlined, but in general, we will get the improvement. So the code on the left is code with the trick. And in this year, it was a very popular micro-optimization technique on GitHub. So recently, 4 weeks ago, Microsoft decided to change the behavior of the inlining. If throwing is conditional, it will be inlined. No more need for the trick, but it will apply only to .NET Core 1.2 and the next version of desktop.NET. So today we still need to do this trick. And next benchmark. I wanted to benchmark how much does it cost to throw an exception. But the problem was that I could not stop the stopwatch before I caught this exception. So it was impossible to benchmark, at least for me. And I decided to compare 3 things. We catch and throw, we throw and catch, we go with the try out pattern, which simply returns false. And if it's not okay, if it's okay in the out variable, you will have the result. And we return failure with a simple structure which can contain value or the problem. And I have compared these 3 methods. So catching and throwing exception is 3,000 times slower than simply returning false. This is why people do a lot of ugly try-out stuff. But do we really need to? Okay, maybe not yet. This is also dependent on the depth on the call stack. So if catch is just on the same line, the cost is different. But if we have a catch and few methods in between catch and throw, then we have a different distance. And CLR, when it's handling exceptions, it's looking through the stack and searching for each of one for exception handling blocks. So usually we don't pay the 5 milliseconds, but more, something like 10. But do you think that we should be afraid of this cost? Is it a big problem to us? No. In my opinion, no. But why? Exceptions should not be used for things that you would expect that are common. So if you have a web application and user sends you an input, he can be wrong. So you just validate the input. You don't throw exceptions. Exception means that something very bad happened. And this should be left only for the exceptional situations. And this is why I believe that we should not be using exceptions for controlling the flow. And this is easy to say, harder to do. So in our code base, we have introduced something like result, which has a value or the error. And if we are OK, we return the value. If we are not OK, we simply return error, which is just a wrapper for the string. And it costs almost nothing. So I really recommend you to do so. And the other best practice that we introduce is that we have configured all of our client instances to send us bug reports about exceptions to our private emails. So the first day, we received like 200 emails, each of us. And then we decided to go to the code and fix the places where it should not be an exception. So we have eliminated all of the common scenarios. And today, I'm on holidays. And if I get an email from our configuration, that it means that something bad really happened and that I should be worried because there was an exception. Something wrong that we did not prepare to happened. So, to sum up, finally can override current exception. And we are going to fail, and we just need to be prepared for that because nothing is guaranteed. Also, exceptions get wrapped when using reflection or static constructors. And native exceptions are translated to corrupted state exceptions, and we cannot catch them by default. Also, async await does not handle very well the aggregated exceptions. But it's not a common scenario to use parent-child hierarchy, so we don't need to be very afraid of that. The next thing that you will do on Monday is not to go from async await back to the continue with. Just think of it if you are using the child tasks anywhere. If so, then you can apply this technique. And please don't fire and forget the tasks, because at some point of time, it might be a really bad problem for you, or a silent error, and we want to avoid both. And exception handling is very expensive, so use the trick today, or just don't throw exceptions in common places. In places when you expected that something wrong might happen. And today I have shared my experience with you and knowledge, but the knowledge most of all comes from great books, which I would like you to recommend and to read. First of all, CLR via C#, great book that gives a great explanation how CLR works. The second one, .NET IL Assembler, by the way, written by a Russian guy, which tells you everything about IL and also exception handling. The most detailed book about exception handling in the world. And the third one, Pro-Asynchronous Programming with .NET, which explains how to work with exceptions in asynchronous world and gives a very detailed information about that. And two websites. One is Breaking Changes in .NET Core, if you are using .NET Core, and the other is an old explanation of constrained execution regions, which is already in Web Archive.